Top 20 AI engineer interview questions and answers. 1. What is artificial intelligence AI? Artificial intelligence AI refers to the simulation of human intelligence in machines programmed to perform tasks that typically require human cognition, such as learning, reasoning, problem-solving, and decision-making. AI systems can be categorized into narrow AI, which is designed for specific tasks, e.g., voice assistants, and general AI, which aims to perform any intellectual task a human can do. AI technologies include machine learning, natural language processing, computer vision, and robotics. Its applications span industries like healthcare, finance, transportation, and entertainment, revolutionizing how we interact with technology and solve complex problems. 2. What is the difference between AI, machine learning ML, and deep learning DL? AI is the broad field of creating intelligent machines, while machine learning ML is a subset of AI that focuses on enabling systems to learn from data and improve over time without explicit programming. Deep learning DL, a further subset of ML, uses neural networks with multiple layers to analyze complex patterns in large datasets. While ML relies on structured data and feature engineering, DL automatically extracts features, making it ideal for tasks like image and speech recognition. Understanding these distinctions is crucial for designing appropriate solutions for specific problems. 3. Explain supervised and unsupervised learning. Supervised learning involves training a model on labeled data, where the input and corresponding output are provided. The model learns to map inputs to outputs, making it suitable for tasks like classification and regression. Unsupervised learning, on the other hand, deals with unlabeled data, where the model identifies patterns or structures on its own, such as clustering or dimensionality reduction. Semi-supervised learning combines both approaches, using a small amount of labeled data and a large amount of unlabeled data to improve learning efficiency. 4. What is overfitting, and how can it be prevented? Overfitting occurs when a model learns the training data too well, capturing noise and outliers, which harms its performance on unseen data. This is common in complex models with too many parameters. To prevent overfitting, techniques like cross-validation, regularization, e.g. L1/L2, pruning and dropout in neural networks are used. Additionally, increasing the size of the training dataset and simplifying the model can help improve generalization. 5. What is a neural network? A neural network is a computational model inspired by the human brain, consisting of interconnected layers of nodes, neurons. Each neuron processes input data, applies weights and biases, and passes the result through an activation function. Neural networks are used for tasks like image recognition, natural language processing, and predictive analytics. Deep neural networks with multiple hidden layers excel at capturing complex patterns in data, making them a cornerstone of modern AI. 6. What is backpropagation? Backpropagation is a training algorithm used in neural networks to minimize errors by adjusting weights and biases. It works by calculating the gradient of the loss function with respect to each parameter using the chain rule of calculus. The gradients are then used to update the parameters in the opposite direction of the gradient, reducing the error over iterations. Backpropagation is essential for training deep learning models efficiently. 7. What is the bias-variance trade-off? The bias-variance trade-off is a fundamental concept in machine learning. Bias refers to errors due to overly simplistic assumptions in the model, leading to underfitting. Variance refers to errors due to the model's sensitivity to small fluctuations in the training set, leading to overfitting. A good model balances bias and variance to generalize well to unseen data. Techniques like regularization and ensemble methods help achieve this balance. 8. What is gradient descent? Gradient descent is an optimization algorithm used to minimize the loss function in machine learning models. It works by iteratively adjusting the model's parameters in the direction of the steepest descent of the loss function, as determined by the gradient. Variance includes stochastic gradient descent (SGD), which updates parameters for each training example, and mini-batch gradient descent, which uses small batches of data. Gradient descent is crucial for training models efficiently. 9. What is reinforcement learning? Reinforcement learning, RL, is a type of machine learning where an agent learns to make decisions by interacting with an environment. The agent receives rewards or penalties for its actions and aims to maximize cumulative rewards over time. RL is used in applications like game playing, e.g., AlphaGo, robotics, and autonomous systems. Key components include the policy, reward function, value function, and environment model. 10. What is a convolutional neural network, CNN? A convolutional neural network, CNN, is a type of deep learning model designed for processing grid-like data, such as images. CNNs use convolutional layers to automatically extract spatial features like edges and textures, followed by pooling layers to reduce dimensionality. Fully connected layers then classify the features. CNNs are widely used in image recognition, object detection, and computer vision tasks due to their ability to capture hierarchical patterns. 11. What is natural language processing, NLP? Natural language processing, NLP, is a branch of AI focused on enabling machines to understand, interpret, and generate human language. NLP techniques include tokenization, sentiment analysis, machine translation, and named entity recognition. Applications include chatbots, voice assistants, and text summarization. Advanced models like transformers, e.g., GPT-BERT, have significantly improved NLP performance by capturing context and semantics. 12. What is a generative adversarial network, GAN? A generative adversarial network, GAN, consists of two neural networks, a generator and a discriminator, that compete against each other. The generator creates fake data, while the discriminator tries to distinguish between real and fake data. Through this adversarial process, the generator improves its ability to produce realistic data. GANs are used for tasks like image synthesis, style transfer, and data augmentation. 13. What is transfer learning? Transfer learning involves leveraging a pre-trained model on a new, related task to save time and resources. Instead of training a model from scratch, transfer learning fine-tunes the pre-trained model on a smaller dataset. This approach is particularly useful in deep learning, where training large models requires significant computational power. Applications include image classification and LP and medical imaging. 14. What is the difference between classification and regression? Classification and regression are two types of supervised learning tasks. Classification predicts discrete labels, e.g., spam or not spam, while regression predicts continuous values, e.g., house prices. Algorithms like logistic regression and support vector machines are used for classification, whereas linear regression and decision trees are used for regression. Understanding the problem type is crucial for selecting the right model. 15. What is a decision tree? A decision tree is a supervised learning algorithm that splits data into branches based on feature values to make predictions. Each internal node represents a decision rule, and each leaf node represents an outcome. Decision trees are easy to interpret and visualize, but can overfit. Ensemble methods like random forest and gradient boosting improve their performance by combining multiple trees. 16. What is a random forest? A random forest is an ensemble learning method that combines multiple decision trees to improve accuracy and reduce overfitting. Each tree is trained on a random subset of the data and features, and the final prediction is made by averaging, regression, or voting classification, the outputs of all trees. Random forests are robust, handle missing data well, and are widely used in predictive modeling. 17. What is the curse of dimensionality? The curse of dimensionality refers to the challenges that arise when working with high-dimensional data, such as increased computational complexity and sparsity. As the number of features grows, the volume of the data space expands exponentially, making it harder to find meaningful patterns. Dimensionality reduction techniques like PCA and TSNE help mitigate this issue by reducing the number of features while preserving important information. 18. What is a support vector machine, SVM? A support vector machine, SVM, is a supervised learning algorithm used for classification and regression. It works by finding the hyperplane that maximizes the margin between classes in the feature space. SVMs are effective in high-dimensional spaces and can handle nonlinear data using kernel functions. They are widely used in applications like text classification and image recognition. 19. What is the difference between bagging and boosting? Bagging and boosting are ensemble techniques that combine multiple models to improve performance. Bagging, e.g., random forests, trains models independently on random subsets of the data and averages their predictions, reducing variance. Boosting, e.g., eta boost, gradient boosting, trains models sequentially, with each model focusing on the errors of the previous one, reducing bias. Both methods enhance model accuracy, but have different use cases. 20. What is the role of ethics in AI? Ethics in AI involves ensuring that AI systems are designed and deployed responsibly, considering fairness, transparency, accountability, and privacy. Issues like bias in algorithms, job displacement, and misuse of AI technologies highlight the need for ethical guidelines. AI engineers must prioritize ethical considerations to build trust and ensure that AI benefits society as a whole.